I will be recording the whole session, like I said. So let me just let the last few people in. Okay, so my friends that are joining us now, if you wouldn't mind, please take out your study guide or open it up on your computer because we are going to be going through it. It is going to be This is going to be your time to ask me questions about the study guide. So please make sure that you have the study guide out and ready to go over because we will be going through it. You will have the opportunity to ask questions for the tests that you will be taking tomorrow and Friday. Okay. So I have two more people that aren't in yet. One of them usually attends. So I want to wait another minute just to see if he will join us. If not, we're going to get started. So please make sure that you have two things. First, it must be something on your end. Let me get the chat open. Can everybody else hear me? Abby, can you hear me? Shake your head. Yes. Cool. Thanks, Abby. Wonderful. So if you can't hear me, I mean, never mind. You're good. Just make sure you have the study guide open. We're going to start to go over in another minute. We're going to see what happens if someone's going to join back in. So let's just wait a minute for them to try that out. And then we will go from there. Let me just let him in, see if it helps. Can you hear me talking, Nasim? Oh, he's not in the meeting. Didn't I just let him back in? Let's try that again. Let's try that again. Sorry guys. Let me just boom. Let me just wait for him to see if he can hear me talking. And then if not, he'll have to just watch the video after. Maybe? Not trying to be rude. Let's see. Okay. So what we're going to do, I'm going to start to share my screen and let me just, my watch is itching me. Boom. Okay, I'm going to share my screen and you need to make sure that you have your study guides open. I'm going to leave the ability to unmute yourself on. You're going to have the ability to chat with me. So please make sure that, I know that I do this a lot, but I just want to make sure everybody's really clear. Let's make sure that we're being appropriate. And just while I'm sharing my screen, you have the ability to talk, like to unmute yourself. So let's just use that wisely. Okay, so what I'm going to do, let me just sort of pull this out of the way. I'm going to throw this up top here. And we're going to be looking at our review sheet for today. As we go through, if you have questions, please throw them in the chat so that I can answer them. I'm going to walk around and I'm going to start writing on the board. So let's make sure that we are ready with this and we can get started. So let me walk around and get set up. I'm going to flip my camera as well so that you can sort of see me a little bit better. We'll try that. Why not? Okay, so what we're going to be doing is we're going to be looking at these box and whisker plots that show the number of miles James and Angie ran per day in June. We can troubleshoot that at the end, Max, okay? And if you come in on Friday, you guys are taking it on Friday. When you come in on Friday, just bring it with you, and then I can mark you down as having it too, if we can't figure it out, okay? Okay, here we go. I'm going to close that chat, and let's take a look at these box and whiskers that talk about James and Angie's running for the month of June. Okay, so if we look at this first statement, we need to decide, is it true or false based on our data that we're given here in these box and whiskers. Okay, so as I'm going through, if you have questions, please unmute yourself and ask them or throw them in the chat, because it lights up at the bottom when I get chat things. So just let me know and I can answer those as I'm going. Also, if I'm going too fast or you need more explanation, throw that in the chat as well and I can slow down. Okay, so Angie typically runs further than James. So if we're looking at Angie's data, we're going to be looking, when we're talking about typically, we're going to look at this interquartile range data, because that represents 50% of our data, right? So if we're talking about typically how much further he runs, typically could also be talking about this median value. So if we're looking at those median values or those interquartile range boxes, we can say that, yes, Peyton, perfect. This is a true statement. Very good. The middle half of the data for James has more variability than the middle half of data for Angie. Let's see. Max, what did you think about this one? Did you think this one was true or did you think this one was false? Max said he thought this one was true. Very good. And the way that we can tell about the variability of our data when we're looking at a box and whisker plot is we can look at the size of this interquartile range box. The larger the box, the more variability in our data. We can also look at the range of our total our total box and whisker. Both James has a larger range and he has a larger interquartile range box. Remember that variability mostly depends on the size of the interquartile range, but it also can take into account the size of the range overall for the whole set of data. Okay, good. Now, the median distance run by Angie is less than the median distance run by James. What did you think about this one, Gwen? And let's unmute ourselves instead of throwing them in the chat, because I think it might be faster if we unmute ourselves. Good, moving forward. So we have this guy here, and Gwen said this was false. Very good, because the median run by Angie is further along. It's between that 9 and 12, and James's falls between 3 and 6. So we're going to say that one's false. Very good. Now, the interquartile range, the IQRs for Angie and James are equal. What do we think about that one, Cam? True statement? False statement?
I said that they aren't equal.
Good. And how did you know that?
Because the interquartile range for James was 9. No, not 9. Yeah, 9. And then the one for Angie was 3.
Perfect. Awesome. So Angie's was 4 and James's was 9. Very good. False statement. 50% of the day, 50% of the days in June, Angie ran between 9 and 12 miles. Okay, let's think about that one. What do you think about that one, Cindy? True or false? Cindy said true, very good. Because if we look at this interquartile range box, the interquartile range falls between 10 and 12. And remember, the interquartile range is made up of two parts, right? The first half of the box and then the second half of the box. Each half of those boxes is worth 25%. Very good. Now, we can determine that Angie ran more miles per day than James on every day in June, except for one day. Can we make that determination just by looking at the data, Ava? Throw it in the chat, Ava, yes or no? Can we make that determination? Let's see. She said no, very good. We can't make that determination because we don't have our actual data set. It could be, there could be in this section right here, there could be 5 days, there could be 2 days. So we don't know. Very good, nice job. That's a false statement, very good. Let's take a look at the bottom half of this. I'm gonna start to go a little bit faster, guys, just so that I don't use up all your time today. Let's take a look at the bottom here. Okay, so the double dot plot shows the hours in hours for flights for 2 different airlines flying out of the same airport. Okay, so the flight time for Airjet Express has greater variability than the flight times for cross-country air. What did we think about this one, Kyle? Is it true or is it false? Is it true or is it false, Kyle? Okay, that was not the expectation, Kyle. The expectation was that the packet was out and ready to go. The flight times for Airjet Express have greater variability than the flight times for cross-country air is, in fact, true. Because if we look at our data for cross-country airlines, it's more compactly it's more compact, right? It's more together. When we look at our spread for Airjet Express, we have more space in between our points and it's more spread out. Very good. Okay, the standard deviation for Airjet Express is equal to the standard deviation for cross-country air. I would have to say for that one, let me see. Elliot, very good. That is a false statement. Very good, Elliot. Because we said that this is more spread. The variability is larger. So the variability, the standard deviation in turn is going to be larger for Air Express. Very good. They're not going to be equal because they're not both symmetric. Awesome job with that one, Elliot. Perfect. The mean time for Airjet Express is greater than the mean time for cross-country airlines. If we're thinking about that mean time, what do we think about that one? Let's see. Sadie said that one was false. Very good, Sadie. And let's see why. So the mean time for Airjet Express is greater than the cross-country airs. And we're going to say that is false because most of our data is skewed to the right on this time. So that means most of our data is on the left side of our graph. So our mean value is going to be more towards this end of your data than this one that falls directly at 5. Very good, nice job. And the way that you could have tested that statement is you could have taken all your data points, put them into your calculator and calculated your mean for both of those. Nice job. Now, the mean is equal to the median for cross-country airlines. What do we think about that one? Kyle said that one was true. Very good. And the reason we can say that one is true is because cross-country airlines is symmetric in its distribution, right? So when it's symmetric, you're going to have a mean that's equal to your median. Very good. Nice job, Kyle. Let's take a look at the next page. We have some more true false, and then we're going to move into some other types of questions. Here we go. Okay, so the dot plots show the sizes, the shoe sizes for two different groups of people. Okay, the mean and the median values of shoe sizes shown in dot plot A are the same. So are the mean and the median the same for group A? What do we think about that one? Connor, what do you think about that one?
I said false.
Very good. And why do you think that? Okay, so the mean and the median, the only way that they're going to be equal to each other is if you have a symmetric distribution. If you look at this, we have an outlier over here, so we cannot say that this is a symmetric distribution. So our mean and our median values are not going to be the same. Very good, nice job. The median values of the shoe sizes shown in the dot plots for the two groups are about the same. Let's see. Yep, no problem, Tyler, you're good. If we're looking at this one now, are they about the same? Let's see. We have a median here. Our median is going to fall in this category right here. It's going to fall at 8. Our median on this one here is going to fall on this 9.5. So those are not about the same. I would not designate those or classify those as about the same. Okay, that's no problem, Kyle. Thank you for letting me know. So we're going to say that this is a false statement because we have a median on our first one of 8. In our second one, we have a median of 9.5, which those are not about the same. About the same would be like 8.2 versus 8.4, okay? When the highest shoe size in group A is removed from the data, the median will remain unchanged. So when we get rid of that, what do we think about that? What's going to happen to that median there? Kyle said it's true. Very good. Nice job. Because if we were to take this guy out and we were to calculate our median, counting off pairs, working our way in, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Our median would still be 8. Nice job. When the highest shoe size in group A is removed from the data set, the mean will change more than the median. And we know that when we take an extreme value out, we know that the mean is going to do what? Let's see what people are saying. Peyton said it's true. Kyle said it's true. Very good, because remember, the mean is more susceptible to change due to extreme values. When you have extreme values, your mean value is more likely to change. Awesome job, Kyle, and nice job. So the dot plot below shows the points scored in a game by a member of two groups. Without a calculator, is the standard deviation of the points scored larger for group A or group B? What do we think about for this one, John? Is it larger for group A or for group B, John? What do you think? Thank you, Gwen, but I'm going to see if John can help us out on this one. John said A. And why do you think that, John? Why do you think that A has a greater standard deviation? Think about what standard deviation looks like. He said that there's a gap at the start. Let's see. Remember that when we're talking about standard deviation, we're more talking about the spread of our data. How spread out is our data? This first one here is definitely, I would say, except for that extreme, more compact. This guy here, we have a lot of values over in the 41s. We have a space here, and then we have these values in the 50s. These ones are more centralized in this area, whereas we sort of have two separate peaks in this group B. So we're going to say that group B has more. or has a larger one. Sorry, I forgot what the question was asking. Has a larger one. Very good. And how do we know that? Because our data is more spread out. When you're not asked to calculate standard deviation, but to tell me which one has a greater standard deviation, you need to look at the spread of your data. How spread out is it? Is there space between it? You're also going to look a little bit at the range of our data. Very good. Okay, so we're going to say that A or B has a larger one because it's more spread out physically. When we're talking about physically, just looking at it without calculating, we need to look at the spread of our data. Good. Let's take a look at the next piece here. This was probably the most challenging because we haven't done much of this in class. So we had to create a histogram here, and we can do it one of two ways. You could have started it at 0 here and then gone 0.5, 1.5 or 1, sorry, 1, 1, 1.5, 2, 2.5, 3, 3.5, and then 4. Or you could have started it just like starting at 0.5 on that axis. I'm going to leave the 0 there because I already wrote it like that and I don't want to rewrite it. So now we need to go through and we need to fill out our frequency chart here. So the frequency chart you can fill out one of two ways. You could just go through and count all your values and write the number in the box here, or you can go through your list and like go through each one and say where would it fall. It would fall, this first one would fall in this range right here. This one, yes, nice job, Connor. Okay, so we have, when we go through and we create our frequency chart, once we create our frequency chart, that's probably the best thing to do first was to create the frequency. We have 4, we have 7, we have 4, 3, 2, 2, and 1. So what we needed to do here is we needed to now fill in our ranges. So from 50 to 99 cents, that would be this column right here. What's going on? Okay, don't know why that's not working, but we have 4, so I should fill in 4 of these boxes. Why is this not working? 1, 2, 3, 4. Okay, now in this one next door, we have 7, so we're going to fill in 1, 2, 3, 4, 5, 6, 7. Okay, and I'm using different colors so that you can see the difference here. You don't necessarily need to use 2 different colors. Now we have 4 in our next column here. 1, 2, 3, 4. And in our next one, we have 3. And then in our next one, we have 2. And, oh, 2. And then check that chat. Someone just threw something in there. Give me one moment. For which 4? So let's go through. Okay. So we have, yep, let me go through. Okay. So we have 99 cents, which falls in here. Okay. 139 falls in this one here. Let me go through and let me do this different colors. We have 175, which falls in here. We have 122, which falls in this category. We have 145, which falls in this category. We have 220, which falls in this category. We have 75, which falls in this category. 123 falls in the second one. 125 falls in the second one. 175 falls here. 299 falls in this category because this goes until 299. 275 also falls into this category. 169 falls into this category right here. 125 falls into this category right here. 309 falls into the second to last one. Okay, 199 falls into the third one. $2 falls into the fourth one because we're looking at $2 to $2.49. Okay, 79 cents falls into the first category. Okay, now 132 falls into the second one. 225 falls into the 4th one. 315 falls into the 6th one. 385 falls into the last category. And 52 cents falls into the first category. That is how I got all of my frequencies. And then I counted up the number of tallies in each column, and I got 4, 7, 4, 3, 2, 2, and 1. Does that make sense, Peyton?
Yes, it does.
Awesome, thanks, my friend. Okay, what I'm gonna do is I'm gonna erase, and then if you need to look back at this, you can look back at the video when I post it after this meeting, okay? Let's take a look at the next piece. Okay, so are the mean and median equal? If not, which is greater? So when we looked at this data here, we're gonna say that they're not equal, because they're not symmetric. Okay, so now we need to think about which one is going to be greater, our mean or our median. And we're going to, because our data was skewed, where most of it was was on the left side, so that means it's skewed to the right. When we have data that's skewed to the right, typically our median is going to be larger, because our mean, that means our mean has a lot more smaller values in it. So the mean is going to be smaller. So when we have data that's skewed to the right, we're going to say that our median is greater, because our median is our median is greater because, sorry guys, when we have data skewed right, our median will be larger. Does that make sense? So when we have data that's skewed to the right, typically our median will be larger, will be a larger value than our mean. Good. So the box plot to the right summarizes data for the number of eggs laid per day by chickens on Miss Fisher's farm. Let me check that out. Okay, perfect. Somebody was just giving me an answer. What is the median of our data set? The median, like Kyle said, is going to be that number that falls in the center here. And when we find that value in the center of our box there, or not in the center of our box, but the line that falls inside of our box, it falls at 6. We have a median of 6, which is lower. The number of eggs laid in one. What is the lowest number of eggs laid in one day? Kyle said 2. Very good. And let's see where that would fall in our box. The lowest number of eggs laid per day would be at the far left end of our whisker, and that would be 2 eggs. Very good. What is the first quartile, Q1, of this data set? If we follow the edge of our box, let's see what people are saying in the chat. Allison said 3. Tyler said 3. I'm sorry, Gwen said 3. Kyle said 3. Very good. Let's see why. If we follow and find the far left edge of our interquartile range box. It falls on our graph or our number line here. And we would have to use the scale that we have. So it would have a first cube value of 3. Good. What percentage of the chickens laid 6 or more eggs? 6 or more. Let's see. Kyle said 50%. Let's see. A couple other people put things in as well. Tyler said 50%. Gwen said 50%. Awesome job. And the reason we say 50% and not 75% is because 6 falls here. And we're looking at all this data that falls above. I have this region, which is 25%, and this whisker, which is worth 25%. So you add it together to get a total of 50% of your data. Very good. Nice job, guys. Let's take a look at the next piece here. Okay, the dot plot shows how long it took for a dart to hit a dartboard. Okay, so data plot 1, dot plot 1, dot plot 2. Are the mean and the median values on dot plot 1 the same? What do we think? Are they going to be the same? Gwen, what do you think? Are they going to be the same or are they going to be different? Gwen said they're going to be the same. Very good. And we know that they're going to be the same because it's symmetric data. So we're going to say they will be the same. Every single question that I'm going to ask you, I mean, not every single question, but a lot of the questions I'm going to ask you on this test are going to be, are they the same? That's part 1. And then part 2 is going to be explain your reasoning. So you cannot say just yes or no. You need to tell me why. They will be the same because because it is symmetric data. Very good. You need to have a good reason why when it asks you to explain your reasoning. Good. Are the mean and the median values shown in dot plot 2 the same? Why or why not? What do we think for this one? Let's see. Kyle said no. Gwen said no. Peyton said no. Awesome. And yes, you are correct. We are not going to have a median, a mean, the same value. They are not going to be the same. And why do we know that? Because it's not a symmetric distribution. Let me just check this chat. Some people put stuff in here. Very good, Kyle, because it's not symmetric. Very good. We said because it is not symmetric. Very good. Because when you explain, because A-U-S-E, it is not symmetric. Very good. Nice job. Let's take a look at the next piece here. I'm going to scroll. Okay. Is the median greater in plot 2 or plot 1? Explain your reasoning. So which one has a greater mean or median value here? The plot 1 or the plot 2? Somebody put something in the chat. Sorry. Let me just try to get there. Okay. And very good. We're going to have medians in this case that are equal. Very good, Connor. Nice. So is the median greater in plot 1 or plot 2? They are the same. Because, let's see what our reasoning would be. Because if you were to calculate it to find that center value, they would both be equal to what? What were they both equal to, Connor? median, M-E-D-I-A-N, they would be equal to, let's see what Connor said. I'm assuming that he had it right because he already checked his. 1.4. Nice job, Gabe, Max, and Connor. Perfect. They would both be equal to 1.4. Very good. Okay. Is the mean greater for plot 1 or plot 2? Explain your reasoning. Which one's going to have a greater mean now? Which one's going to have a greater mean? I see Gwen's typing. Let me pull up the chat. Gwen said plot 2 is going to have a greater median. And let's see what we think here. Let me scroll back up so that we can look at those plots together. So a couple people are saying plot 1, a couple people are saying plot 2. Because plot 2 has these two values here that are smaller, it's going to drag that mean down towards the left side. It's going to make that mean a lot smaller. These two small outliers are going to bring that mean value down. So we're going to say that which one has the greater mean is going to be plot 2 because, plot 1, because that in plot 2, those two outliers pulled it down towards the end. Good. Nice job. So we're going to say plot 1 will be larger because the two, and then we can say extremes or outliers will pull the mean in 2 down to be smaller. And you could just say it'll pull the mean to be smaller, but I sort of got a little bit wordy there. So plot 1 is going to have a larger mean because the extremes in plot 2 are going to pull that mean down smaller. Okay. So now, if a dart is thrown and it takes 4 seconds to hit the dartboard, a dot is added on plot 1 at 4 seconds. Will this new data affect the median or the mean more? Which will be affected more easily? Kyle said that it's going to affect the mean more. Gwen said it's going to affect the mean. Gabe said mean. Peyton said mean. Very good. It's going to affect the mean more because the mean value is more easily affected by extreme values, and 4 is an extreme value. Because it falls outside of our main data set, we're going to call for an extreme value. Good. Is the standard deviation greater in plot 1 or plot 2? What do we think for this one, Ava? Is the standard deviation in plot 1 or plot 2 going to be larger? And yes. So Ava said that the standard deviation in 1 is going to be larger. Who else can give me another idea? Do we agree with that? That the standard deviation in plot 1 is going to be larger than the one in plot 2? Gabe said he doesn't agree. Kyle said he agrees. Gabe said plot 1. Gwen said plot 2. Gabe changed his mind. He said plot 2. Okay, so let's take a look at why plot 2 is going to have a larger standard deviation. Plot 2 is going to have a larger standard deviation because it has those extreme values. Those extreme values, just like we said when we said the mean is more greatly affected by, nice job, Gabe. Just like when we said the mean is more easily affected by outliers, standard deviation and mean go hand in hand. So because the plot 2 has a greater mean, a smaller mean, it's gonna the standard deviation is gonna be a lot larger on plot 2 because extreme values cause for a larger standard deviation. And we can think about it this way, okay? So we have our standard deviation, and the standard deviation talks about the average distance between our mean value and all of the other values. When we have values that are really far outside of our data set, that are either really small or really large, that's going to bring that average distance way up. So when we're looking at the standard deviation, we're talking about the variability, or like the average distance between our mean value and each one of our points. If we have nice compact data like we do in that first one, we're going to say that the standard deviation is pretty low. The average distance from our center to our points is going to be a lot lower. So the plot 2 is going to be a lot larger because we have those 2 data values that are outside our main data set, and that's going to make our average distance a lot larger. Okay? That's what we need to think about when we're thinking about standard deviation. We're talking about the variability or the spaced outness of our points on our plots here, okay? So make sure that if you got that one incorrect, you made a change, please. Make sure if you got that incorrect, you're making a change, please. Let me move us down a little bit. Okay, so we're talking about Miss G's first grade class, collecting data about the number of raisins found in a small package of raisins at snack time. The dot plot below represents their data, right? So the data contains one outlier. What's the value of our outlier? And explain how you know. So someone in the chat, throw out Max. What did you think the outlier was? Kyle said 14. Gwen said 14. Max said 14. Perfect. Our outlier is 14. And the reason that it's our outlier is because it falls outside. It falls way outside of our main pack of data because it falls far outside our main, and then I said pack, or you could say set of data. Okay, because it falls way outside of our cluster of data, we're going to say that it is in fact an outlier. So Griffin suggests removing the outlier from the data set because it doesn't fit with the rest of the data. Is this the right action to take? Do we think we should remove the outlier? Kyle says it doesn't fit his data. But Peyton's saying no, Gwen's saying no, Sadie's saying yes. So why don't you, my friends that had said either no or yes, why don't you throw in the chat, or Peyton, why don't you unmute and tell me, why do you think we should not get rid of it?
Because even though it's an outlier, you still have to count it as your data because it was just that's so
very good. That even though it's an outlier, we still have to keep it because it could be a true data point. Good. And Sadie, I'm not saying she's right or wrong. Sadie, why do you think we have to keep, or why do you think we want to get rid of it? I'm gonna wait. I think Sadie's gonna write it in the chat. Let's see what she says. Why do you think we want to keep it? We're going to give her another 10 seconds. So Sadie said, because not many people have it and it's far from our other data. But we want to make sure that when we're talking about removing an outlier, we only really do it in extreme cases. And we really need to think about how that, if it was an error, why it occurred. Okay, so we're going to say, the correct answer for this one is, are we going to get rid of it? No, we're not going to get rid of it. Because it's a true data point, right? So someone could have really, just because it's really far outside of our data set, doesn't mean I couldn't get a box of raisins and have it be a mistake and have only like 14 in my box when everybody else has 30 in their box. Just because I think because like if we had gotten like a number like 3, then maybe we could think about getting rid of it because then maybe the person ate all of the raisins. But this is a reasonable, there are mistakes that happen at factories, right? So we're not gonna get rid of it because it could be a true data point. I mean, you could say we're talking about first, I mean, if you had put down there, yes, get rid of it. And then your reason was something like, because first graders don't know how to count. I would probably take that as a correct answer because you gave me a reason, a reasonable reason to back it up. So I'm not saying like this is 100% definite you don't get rid of it or 100% definite you do get rid of it. You need to just make sure that you have a reasonable reason why. Okay, and don't just say because it falls outside of our data set, because we already know that you don't get rid of an outlier just because it falls outside of our data set. You have to have a valid reason in the story of your data to get rid of it, to justify getting rid of it. So you can say you could get rid of it. And if you gave a reason like because sometimes first graders don't know how to count, that one I would say I accept. And I would give you full credit for that. But you just need to make sure you have a reasonable reason and you don't just say because it falls outside of our data set. That is not a good reason for getting rid of an outlier. Just because it doesn't fit our data is not a good reason, okay? So if the outlier was removed, which would be more likely to change significantly, the mean or the median? What do we think here? Kyle said that the mean, because the outlier won't drag the mean lower when it's removed. Good, because we're going to say the mean, because mean values are more easily affected by extreme values. Okay, so when you have extreme values, it's most of this, if you take out or add an extreme value, you're going to change that mean value. Good. And Gabe added, and he said that it would increase, and I would say 100% correct, Gabe. Perfect. It would increase because you're taking out that smaller value, so it would bounce back up to that main set of data and have a larger mean value. Awesome job, Gabe. Okay, let's take a look at the next piece here. For the data set below, answer the following questions. This is going to go speedy quick, so let's see what people are saying. So what is the shape of this distribution? Kyle said it's symmetric. Very good. How else could you describe this set of data, Gabe? How else could you describe it? bell-shaped. Awesome job. / bell-shaped. Okay. So on this question for the test, it's not going to be a select all. You're going to be given a graph and you're going to say select one of these three that matches it. Hint, there are going to be times when you're given two options and then it says none of the above. There are going to be times when you're going to want to look at that none of the above and you might want to select that none of the above. So just be really careful and read through the directions really closely when you're going through this section of the test, okay? So which one is going to be greater, the mean or the median? They're going to be the same. Very good, Kyle. Because when we have symmetric, we have a mean and a median that are going to be the same. Which measure of center would you use? I would use my mean because it's symmetric and because it takes into account all data points. So we're not going to use the median here because it only talks about physically that one number that falls in the middle. We want to use the mean because it's more representative and it uses all of those data points. Good. Let's take a look and move forward here. Next piece is we're going to look at this next distribution. What do we think about this next distribution here? What is the shape? And what is going to be greater, the mean or the median here? Abby said it's symmetric. Very good. Awesome. Connor said it must also be classified as bimodal. Very good. That's okay. So we said it's symmetric, but we can also call it bimodal, right? Because, oh, that's a slash. Because we have one distinct peak here and we have one distinct peak here. I mean, it would sort of like flow like this, but I would still accept that idea of bimodal for this one. So what's going to be greater, the mean or the median? Kyle says that they're going to be the same. Very good. Because when we have symmetric, they're going to be equal. Good. Which measure of center would we use? We would use the, nice job, Abby, the mean. Very good. Because like we said, we want to use, if we can, we want to use the measure of center that takes into account all of your data points in your set. So because the mean represents the average of all of the points, we're going to, when we can use it, we're going to use it. Nice. What's the shape of this distribution down here? Kyle said bell shape and symmetric. Max said bell shape and symmetric. Let's think about this, Gwen. The reason, or the way that this would be, if we had a point like over here, or like a few points on the left side here, then we could call this guy skewed. But because this is sort of a trickster one, because it's just not zoomed in, our graph isn't really zoomed in, but all of our data falls where this red line is, right? So because it's sort of presented in a sneaky way, but because there's no points over here, there's no points on this side, we can't say that we're not going to be able to say that it's skewed because all of our data falls in this piece right here. So we're going to call it bell shape or symmetric. Okay, and which one's going to be greater, the mean or the median? What do we think, Ava? What do you think, Ava? Which is going to be greater, the mean or the median? Ava said the median. Well, we have a symmetric graph, Ava, right? And if we have a symmetric graph, what do we know about the mean and the median? They are what? The same. Very good. So they are the same. Very good. So because we have a symmetric graph, our mean and our median are going to be the same. So which one are we going to use? The mean, or which was the greater, the mean, or the median? They're the same. Because symmetric graphs have means and medians that are exactly the same. Oh, no, you know what, Ava, that's perfectly fine, not a big deal. Because I knew you knew it, so I sort of wanted to give you a little bit of time to think it through. So awesome, awesome job on that. Fantastic. Let's take a look at the last piece here. What is our measure of center that we would use here? Because it's bell-shaped or symmetric, what do we think we're going to use for a measure of center? Let's see. Adam never showed. That's kind of a bummer. Ian, what do you think for a measure of center here? What do you think, Ian? Mean, very good. Because, like I said, when I can use the center value that takes into account all of my data values, I'm going to use it. Good. What's the shape of this guy here for D? What are we talking about for a shape here, Cindy? What sort of distribution? Be specific this time. What sort of distribution is it, Cindy? Just give me 1 second. I want to see what Cindy thinks, and then we're going to share out. Cindy said skewed to the left. Awesome. And we say that it's skewed to the left because most of our data is on the right side of our graph. That's awesome, Cindy. Perfect. So we're going to say it's skewed to the left. Very good. And when we have a skewed graph, which one is going to be, when we have a graph that's skewed to the left here, which is going to be larger, our mean or our median? So Kyle said the median. And why do you think the median is going to be greater here? Why do you think, Kyle? So we said the median. Let's see, I'm going to give Kyle a second to write, see what he thinks. Okay, so because it's skewed data, our median is going to be, I mean, in some cases when we have skewed data, we are going to have a median that's larger. If it's skewed to the right though, we would have a median that would be smaller than our mean because, so we're going to say that our median is larger because skewed left data will have a smaller mean. Because when we look at this, these smaller values down on this end are going to drag our mean smaller. It's going to drag it to the left, to the left side of our graph. Good. Nice job, Max. That's a good point. Which measure of center would you use for this one? The median. Very good, Abby. We would use our median because we use our median when we have skewed data. Very good. Nice job. Perfect, 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 guys. Wonderful. Let's look at the last piece here. Okay. What's the distribution on this one here? What do we think about this distribution here? Nice job. We would say uniform. Another one that we would use would also be symmetric. Nice job, Kyle. Which one is going to be larger, our mean or our median? When we have a uniform or symmetric, they're going to be the same. And which measure of center would I use would be the mean. Because we're looking at the data point that represents all of our numbers here. Good. Last piece here before we finish up for today. Number 10. The two box plots show the number of seconds it takes two football players to complete. Let me look. To complete a 40-yard dash at two different positions, okay? Does the middle half of the data have more variability in plot 1 or plot 2? So we're looking now at our range in our box here. We're gonna say for two, there's two things you need to look at here. We're gonna say plot 2 has more variability. We can say that we can know that by looking at two different things. First, we can calculate our IQRs, or if we have the same range here on the bottom of our number lines, which box is larger? Okay, so two ways that you can determine whether or not which one has more variability. You're going to look at the size of the interquartile range box, if they have the same range on the bottom, or you would have to actually calculate your interquartile range. Which median is less, plot 1 or plot 2? So I'm looking at my median value now. The median is larger in plot number 2. Because we have 4.82-ish versus 4.5. Okay, nice.
You forgot. It's which one is less, not which one is greater.
Oh, goodness. Thank you, Connor. That was awesome. Read the question. Oh, Mr. Maid is the worst. I'm sorry about that. So which one is less? Thank you for catching that, Connor. Which one's less? We're going to say plot 1. That's why it's really important to read the questions. Because 4.5 is smaller than 4.82. Ish. Okay, nice job. And is it true that every run recorded for plot 1 is less than every one recorded for plot 2? We're going to say that that is a false statement. And the only way that you could say that for sure is if on this bottom one here, it ended like at this point here or further to the left. The only way that you could say that every single run was shorter would be if the two plots sort of were separate from each other. There was no overlap. But because there's overlap here, that's on both of our graphs, we're going to say that that's not a true statement. Very good. Nice job. Okay, so ladies and gentlemen, starting tomorrow, you will have the opportunity to work on the quiz. Let me say a few things. So people that are in school are going to have let me turn this around so you can see me, are going to have a paper copy of the test to work on. If people at home would like to come to the school to pick one up, you can do that. And